Okay guys, so we're going to do 1.14b. This is practice with standard form. Alright, so remember what we're talking about in this lesson is writing standard form equations from context. Alright, so standard form equation is an equation that looks like this. ax plus b y equals c. So we're going to have two variables, okay? And we're going to call that, this is standard form. Okay, so variable 1 and variable 2, two variables, right? Okay, so let's go ahead and read through the question here. It says George is at a craft store and sees two types of decorative beads for a project he is working on: blue square and red circles. So blue square and red circles. So those are going to be our variables, okay? So now if we're going to stop and think about this, it's either going to be a price, it's going to be the price that we're looking for, or it's going to be the number of beads or red square, beads that we have, right? So we got to figure out that by reading the rest of it. Okay, so it says the craft store sells these beads by the pound. So beads by the pound. The blue square beads, they cost $3.50 per pound. The red square, or the red circles cost $1.75 a pound. Okay, so George wants to buy as many beads as he can with the $21 he has. All right, so we're talking about the amount of money here that he has $21 to spend, and all of this is in terms of money. Okay, so the amount of money that we have. All right, so it says write an equation. Write an equation that describes the relationship of the pounds of blue square beads and the pounds of red circle beads that George can buy if he spends all of his money. All of his money? $21. Okay? All right, so it has to deal with money, and we get charged per pound. Okay? So first things first, it kind of skips that part where we are defining the variables, so we got to go ahead and define the variables. All right, so let's do that. And we're going to say B equals pounds of blue square beads. Take your time to write that stuff out and be accurate with it. Okay, that will save you in the long run. All right, so just write those things out so that you know B is going to equal the pounds of blue square beads. So R is going to equal the pounds of red circle beads. Okay? All right, so we know that the blue square beads are $3.50 per pound and the red circle beads are $1.75 per pound. Okay? So for every pound of blue square beads, it's $3.50. So we could represent that by saying, $3.50 or 3.5 B. 3.5, remember, any letter or variable right next to a number, it means multiply. So 3.5 times the number of pounds of blue square beads. Okay, so now to add that to the red circle beads, it's going to be $1.75 per pound. Okay, so we're going to write down 1.75 times what? What variable? The other variable, R. Okay, and that's going to equal that $21 that we have to spend, or that George has to spend. Okay, so now going back up, just remember, going back up, we want an equation that looks like that standard form equation right here. Okay, so there's my standard form equation, ax plus by equals c. So we got one variable, two variables, we have two variables, okay, and we have a coefficient. A is a coefficient, that's the number that you're multiplying the first variable by, and B is your coefficient, is the number that you're multiplying your second variable by, and C is going to be what it's going to, that's going to be the total, what it's going to equal to. All right, so that part right there is answered. So there's my equation. So it says write an equation. Make sure that you go back up and check to see if you've answered the question. Now it says if George buys no red circle beads, okay, so now we're just going to use a little bit of algebra. So if we don't buy any red circle beads, so what we'll have to do is look at the red circle beads and put a 0 in there for, so we're going to say that R equals 0. All right, so go back up to the equation and write that equation down. So 3.5b plus 1.75. Instead of saying R, we're going to write it as 0 because we know that that R equals 0. Right? And I'll write down 21. Okay? Now I can cancel this out. I can cross that out because I know that 0 times any number is 0. So all we're left with is 3.5b equals 21. Okay? All right. So what I'm going to do is isolate b. If b is being multiplied by 3.5, then in order to get rid of multiplying by 3.5, I divide by 3.5. What I do to the left side, I have to do to the right side. So I divide by 3.5. Okay? Now, just as a guesstimate, how many times does 4 go into 21? Or how many times does 4 go into 20, right? It's going to go in there 5 times, right? So this is going to be 5 something, 5 point something. So as an estimate, it should be somewhere around 5 something. All right? Now, how do we do that with a calculator? Go ahead and open this thing up, and we're going to say 21 divided by 3.5 equals 6. All right. All right, so b equals 6. All right, and it says, so they're showing my work, and it says how many pounds of blue square beads can he buy with his $21. So you always want to restate the question back when you're answering it. So we're going to say George can buy take your time and do this, right? Can buy 6 pounds of blue square beads. Okay, to equal the $21. All right. Okay, so now, just as a guess, what do you think the next one will probably be about? Well, if I had a guess right here and I saw the word no in there, I'm guessing that that's probably we're gonna probably replace the other variable with 0. So it says if George buys 0 or no blue square beads, how many pounds of red circle beads can he buy? Show your work, right? So I circle the question. All right. Okay, so this time instead of R being 0, we're going to say that B is going to be 0. All right, so we're going to plug it in and we're going to say 3.5 times 0 plus 1.75 times R equals, again, that $21. We can cancel that out because 0 times any number is 0. And now all we have to do is divide by 1.75. How many times does 2 go into 20? Goes in there 10 times, so it's got to be a little bit more than 10, right? Okay, so R is going to equal, if we can make this 21 divided by 1.75, it's 12. Okay, all right, so we're going to restate that. We're going to say George can buy 12 pounds of red circle beads. Capitalization, punctuation, capitalize first letter, put a period at the end of the sentence, and we're good to go for C. Okay, so now we're down to D right here, and it says, can George purchase 4 pounds of blue square beads and 4 pounds of red circle beads? That's the question. Okay? Show your work, explain your answer. All right? So if at the end, if that amount, that money is greater than $21, that's not possible. If it's less than $21, it is possible. Okay? No matter how much less it is, but if it's even greater by 1 penny, then it's not going to be possible. Okay? So we're going to use that same equation. 3.5 times 4, because we'll say B equals 4 and R equals 4. Just substitute them in there. Plus 1.75 times 4 equals 21. Okay? All right, so I can plug this in. I'm just trying to see if it equals 21. Notice I don't have any variables anymore. Does it equal 21 or less? Okay? So I could also restate that in terms of an inequality rather than an equality. All right? It's got to be less than or equal to 21, right? Okay, I can't purchase it. I only have $21. If it's more than that, I can't purchase it. So when I work this out right here, notice this is a scientific calculator, okay? So if I go to this right here, there's a standard calculator, looks like that. I click on this, it's a scientific calculator. So I can do this whole thing within one step, okay? So I can just type in here 3.5, and then I put parentheses 4, or wait a minute, what I'd have to do I think is multiply it to clear that all out. So 3.5 times 4 plus 1.75 times 4 equals 21 exactly. All right? So this equals 21. So the answer is yes. George can buy 4 and 4. All right, so I'm going to write there, yes, George can purchase 4 blue and 4 red. And we can say because the amount is equal to $21. Instead of writing when I'm writing, I write. When I'm doing math, I use math symbols for the most part. Okay? All right. On to E. Okay? On to E, and then I'll let you guys do number 2. So here's our last one. Now it says, it said 4 and 4, and it says 3.5 and 3.5. Or not 3.5 and 3 and 3.5, 3.5 and 5.5. Okay. All right. So R. Now remember, kind of tricks you. It puts it in a different order. So this one's 3.5 pounds of red circle beads. So R equals 3.5. And B equals 5.5. Okay, so back to our equation, we got 3.5 times B. Well, what's B? B is 5.5, right? Okay, so just remember, back up. We're using that original equation. That one right there, 3.5 B plus 1.75 R equals 21. All right. So we're going to go ahead and add 1.75 times 3.5 and check it out to see if we'll even say less than or equal to 21. Open up the calculator, and in one step we should be able to do that. So we clear what we have in there. So we say 3.5 times 5.5 plus, that's what it is, that gives me a subtotal right there, plus 1.75 times 3.5 equals. All right, so get 25 point, what was it? 375. So it's 25.38. $25.38 is greater than, okay, it's greater than 21. Okay, so no, George can't buy that amount. Okay, George cannot. Okay, why? Well, because this is greater than 21. The amount of money that he had was $21. Okay? Alright, so there are the beads. So if you like jewelry, this is the problem for you. Okay? My dad used to put together jewelry, make some stuff, which was pretty cool, kind of magnetic jewelry, which helps your body too. But, alright, so guys, there it is. And there is, so this one, once again, is 1.14b, and this is problem number 1, and this will give you the tools to put in your toolbox so that you can do number 2. Okay, so number 2 is pretty much, it's pretty similar to that. May ask you a couple different questions here. All right? Does that make sense? Okay, so let's see, we have number 3. We're going to do number 3 here. I'm going to show you how to do number 3 and walk you through that process. Then number 4 is a treadmill problem that you guys can do for some extra credit. Okay? In my class, if you're in Mr. Russell's class. Okay? Alright, so let's do this problem. Let's read this. So remember, ax plus by equals c. That's what we're talking about. We have to be able to put it into this form. Okay, so the two variables are x and y. We can call them whatever we want to call them. So let's read the problem. It says a real estate developer is planning to build a complex with 2 types of apartments. Okay, so we're talking about 2 types of apartments. So you have a studio apartment, which is a small apartment, fit a bed in, a couple other things, but not much. So you got a studio apartment, and it'll take up 700 square feet. And you have a 1-bedroom apartment, and it'll take up 1,500 square feet. Okay, the developer has a total of 95,000 square feet of space to build her apartment complex. Okay, so you got some numbers here to look at. All right, so once again, we read. Make sure that you read carefully. What's the question asking for? It says to write a linear equation that describes the relationship between the number of studio apartments. So write a linear equation. Relationship between studio apartments, 1-bedroom apartments. Okay? That can be developed assuming she wants to use all 95,000 square feet, all 95,000 square feet of available space. Okay? So it's got to equal 95,000 square feet. So in the end, it has to equal this 95,000. All right? Okay, so let's define some variables here. Okay, so let's say that our studio apartments are S. Okay, and it says the number of studio apartments, because that's what we're looking at. It says the relationship between the number of studio apartments, so number of studios. Okay, let's see, one bedroom, let's say n equals one bedroom. I just wrote n because the O would look like a 0. So number of one bedroom number of one bedrooms. Okay, so square footage for the studios are 700, so we're going to say 700 times the number of studios, which is S, plus 1,500 times the number of one bedrooms, which is N. And that has to equal 95,000. Okay, so there it is. There's our, it asks for the linear equation. So this is a linear equation. Okay, remember it looks a little bit different. This is standard form, remember. Looks a little different than our slope-intercept form, which is the main one that we usually talk about. But there's our standard form equation. Okay, now we can, just like it has the two variables, just like everything else. Okay, we have all of the stuff that we need. Okay, and there's the problem. Okay, so we're going to keep going back. Once we have the equation, we're going to keep going back to that to answer the questions. So if the developer, for B, it says if the developer decides to build 50 studio apartments, all right, so 50 studio apartments, how many one bedrooms? So we're going to be solving for, we're going to go ahead and solve for N. Okay, we're going to solve for N because we're looking for one bedroom apartments. All right. Okay, so here's something that I'm going to show you. Okay, what we can do here is rearrange this formula so that before I even plug anything in, I'm just going to be solving for n. Okay, so I can rearrange this to say, I'll rewrite it and I'll say 1,500 n equals 9,500 or 95,000. So without, like, I have the two variables, I'm going to keep the two variables that I have in there, and then at the end I'm just going to plug in the number of studio, because the S50 is going to be the number of studio apartments I have. So S equals 50. I do know that S equals 50. Okay, so if I want to get this 700S over to the other side, I can just subtract 700S and subtract 700S. I can do that in math, right? As long as I do the same thing to both sides, it'll keep the equation balanced. So I get 1,500 N equals 95,000 minus 700 S. Okay, now if I want to solve for just n, get n by itself, I can divide by 1,500. Okay, so over here I'm going to say n equals just rewrite this whole thing right here, right? So all of this that I'm hovering over here, hopefully you can see that, I'm just going to rewrite it right over there. So 95,000 minus 700 S all over 1500. Okay? So to solve for n, 95,000 minus 700 times 50 divided by 1500. Okay? So I take out my calculator and I clear this thing out, and let's see if we can work this out in one step in a calculator. Right, so I'm going to put this in parentheses, okay? So before I go, let me put this all in parentheses. So 95,000, okay? Whoops. Parentheses. 95,000 minus 700 times 50, close parentheses. Okay? So all of that equals 60,000, right? And I'm going to divide that by 1,500. Okay, so n is going to equal 40. All right, so it says if the developer decides to build 50 studio apartments, how many one-bedrooms? Okay, is it a he or a she? He can build 41 bedrooms. I circle it because I don't want it. I want the answer to be very clear. Okay, and maybe not even circle this part right there. That's my answer right there. Okay, but there is the actual answer. He can build. Is it he or he? Is it he or she? Just says real estate developer. He or she, either one. Okay, so if the developer builds 26, now we look at another one, 26 one-bedrooms. Now we're talking about how many studios. Okay, so we still have that same equation. Go back up to the top, plug in the same equation. 700S plus 1500N equals 95,000. Right, so 700S plus 1500N equals 95,000. Okay? And this time we get one bedrooms. We know the amount of one bedrooms, it's going to be 26, so N equals 26. Okay, so we know what N is. We're going to get this N term over to the other side, and we're going to solve for S right now. So this is one way of doing it. There are a couple other ways, but I just want to show you this. It's kind of efficient, I would suppose. Alright, so I get 700. This teaches you, these are inverse operations that we're talking about here. Okay? And I can do that with numbers times variables and different things in math. 95,000 minus 1,500 n, divide by 700, divide by 700. Okay, and there I am. Now I'm going to plug it in, and I'm going to say S is going to equal, I'm just going to plug in the numbers. 95,000 minus 1,500 times 26, right? So I plugged in the 26, you see that? Plug the 26 in there. And then all of that I'm going to divide by 700. Okay, go to my calculator, one step. Okay, parentheses. Or do the top, the numerator is going to be put in parentheses. 95,000 minus 1,500 times 26. Close the parentheses out, and then divide that number by 700. So S equals 80. All right, so the developer can build '80 studios. Okay, now that's 80 studios to meet the square footage. All right. Okay, a couple more here. So it says if the developer builds one-bedroom apartments, only one-bedroom apartments, how many can she, or it's a she, can she build? Would she use all the available space? So two questions here. How many can she build? All right. And the second question is, would she use all of the available space? All right. So only one-bedroom apartments. Okay. So we have S is studios and N is one-bedrooms. So this time we are not going to have S. We're not going to build any studio apartments, just one-bedrooms. So S is going to equal 0. So we're going to go 700 times 0 plus 1,500 N equals 95,000. Cancel that out because 0 times anything is 0, and when you add 0 to something, it stays the same. All right, so now look at this right here. So 15, to make these numbers look a little bit easier, if I got a 0 here, let me cancel this 0 out over here. If I get a 0 here, let me cancel this 0 out over here. If I can cancel the zeros out, basically I'll just say 15. Okay. 15 goes into 950 how many times? All right, well, how many times does 15 go into 90? 15 goes into 90, let's see, 15 goes into 30 2 times, so double that would be 60. Double, another set of that would be, how about 6 times? As a guess, let's see. So 950 divided by 63. 63 times. Okay, so 63.33. All right, so it says how many can she build? She can build, so she can build complete houses (63 complete houses), or complete, not houses, but complete one bedrooms. right, so she can build 63 complete one-bedrooms. Would she, the second question, got to answer that second question, would she use all the available space? So there's 0.33 left over, so the answer to that question is no. She wouldn't use all the available space. Okay, there's a little bit left over. Make sense? Okay. All right. So now, let's see, we got E left, and that's it. And then you guys can do D on your own, okay? So for this one here, it says, can the developer build 70 studios and 31 bedroom apartments and use 9,500 square feet? Why or why not? Okay, so two questions. I got to answer both of them. All right, so S is going to equal 70. N is going to equal 30. Okay? All right, so 700 times 70 plus 1,500 times 30. And that's got to equal 95,000 square feet. Okay? Okay, calculator, check it out. Let's see. All right. Okay, so let's go. 700 times 70 plus, okay, that gives me the answer to that, plus 1,500 times 30. 9,400. Okay, so it does not equal 9,500. Okay, she could make that arrangement. She could make that arrangement maybe, and maybe add another studio. Another, let's see, if the studio is 700 square feet, so another studio, not another one bedroom, because one bedroom takes up 1,500, but she could add another studio in there. All right. So the question is, can the developer build 70 studios and 31 bedroom apartments and use exactly 9,500? So the answer to this question, so no, she cannot use exactly, because that's what they're talking about. They're talking about exactly the 95,000 feet squared. With 70 studios and 30 one-bedroom apartments. Now, like I said, she could put in 700 square foot for another. She could put in another studio into that, so make it 71 studios, and that would get closer to it. It'd make it 94,700. There still would be 300 left over. Okay? That makes sense? We good to go? There you go, guys. That's it.